Hi, this is your host. When fish conquered land, the first vertebrates left the water for good. Around 365 million years ago, life on Earth was very different than it is today. There were no humans, no trees, no insects, and all of the continents were grouped together in a supercontinent called Pangaea. This time is called the Devonian, and while it might not have had any of the animals we re-familiar with today, it did have some of our earliest ancestors. And during the Devonian, something incredible happened that would set the stage for the evolution of all tetrapods or four-footed vertebrates, including us. For the first time, vertebrates left the water and set foot on land. And it's only thanks to fossils found in northeast China that we know anything about this pivotal moment in history. But what did these first terrestrial vertebrates actually look like? What adaptations did they have that allowed them to live both in water and on land? And how did they change the world as we know it? We'll tell you all about these pioneering fishes right now. Now, before we get into these fishy pioneers, let's talk about why scientists are so interested in this period of time. The Devonian was a pivotal time in the history of life on Earth. It was during this time that life began to diversify rapidly. Plants moved onto land and arthropods like insects and spiders came along too, but vertebrates remained stuck in the water. That is until the late Devonian, when the first fish began to crawl up on land. These fish were likely small, only reaching around 20 centimeters in length. But their size doesn't diminish the monumental evolutionary leap they took. Unfortunately, we do and have a lot of fossil evidence from this time period, and we haven't even found a complete skeleton of one of these early fish. So paleontologists are still unsure exactly what they look like. However, we do have a fair amount of information about their anatomy, thanks to the discovery of several well-preserved specimens in China. One of these specimens is a type of ichthyosaur known as a placoderm. Placoderms were a diverse group of armored fish that lived from the Silurian period until the Devonian. And this particular placoderm is known as a macropedal ichthyosaur. Macro means large, pedals refers to the fin on its head, and ichthyosaur means fish lizard. The reason it has this weird fin is because it's actually two modified pectoral fins fused together. It's not clear why they evolved this fin, but it might have been used for mating rituals, attracting prey, or defending against predators. In fact, based on scars found on some individuals, it seems like some fish had more than one of these cranial crests. This particular species also had two sets of jaws. Its first set was made of bony plates and worked like modern jaws. And behind those were a second set of jaws made of cartilage. Unlike modern sharks, the front and back sets didn't work together. Instead, the back set acted independently of the front set. And while scientists aren't sure exactly how these fish used their double dose of jaws, they're pretty sure that the inner set was used to manipulate prey. You see, unlike most other jawed fish, which have teeth on only their first set of jaws, the micropetrosaur had teeth on its second set as well. And this suggests that the inner set acted like a tongue to push food toward the mouth at the front of its head. Like many other placoderms, it had strong, thick armor that covered most of its body. This armor may have been an adaptation to help it survive in its environment. But interestingly, the micropetrosaur had thinner armor than other placoderms. So it may have traded protection for mobility. This is because although the armor was very heavy, it was extremely helpful for getting around on land. Unfortunately, the micropedal itself wasn't one of these early tetrapods. It lived in the oceans during the Middle Devonian, millions of years before the first vertebrates crawled up on land. However, it is closely related to the first land vertebrates, and it gives us clues as to what they might have looked like. Speaking of clues, there's another amazing piece of information we have about these early tetrapods. It comes from another part of China in the form of footprints preserved in stone. These tracks come from a site called the Gupo Formation, and they date back to around 365 million years ago. There are three main tracks, and each one is around 70 centimeters long. While we don't know exactly what kind of tracks these creatures were making, we do know that they were moving on land. To make matters even more interesting, the tracks seem to have been made by at least two different kinds of tetrapods, meaning that the transition to land might have happened independently more than once. These tracks provide us with an incredible amount of information about the physical characteristics of these early tetrapods. For example, the spacing between the toes in each track suggests that they weren't webbed. If they were, the toes would have been closer together. They also suggest that these creatures had 5 digits on each hand and foot. It's possible that all tetrapods branched off from a common ancestor that had 5-fingered hands and feet. But if this is true, then why don't we see this trait in modern tetrapods like us? Well, over the eons, most of us lost 4 of our 5 digits and ended up with just a thumb and a big toe. That's because our ancestors found that having 4 functional digits was redundant. 4-footed vertebrates could get the same thing done with just 4 fingers or toes. And while scientists aren't 100% sure what these early tetrapods looked like, they think they were probably somewhat similar to modern lungfish. Lungfish are the closest living relatives of tetrapods and can be found in both freshwater and marine environments. Some lungfish can grow over 1.5 meters long, and all of them have fleshy lobed fins. These fins are very different from the fins you'd see on a goldfish or a shark, and they're much more suited to life on land. In fact, lungfish can support their weight on land and move around in a way that's similar to how we crawl. Lungfish also have lungs, which allowed them to gulp down air. This adaptation is key to being able to survive out of water. And it is thought that these lungs were a critical adaptation that allowed early vertebrates to make the transition from water to land. However, not all lungfish are created equal. There are 8 species of lungfish alive today, and only one of them has both lungs and the ability to move around on land. That fish is known as the mudskiller and is found in Africa, South America, and Australia. The mudskiller gets its name from its habit of spending time on land, where it wriggles around in the mud to find food. Like many other fish, the mudskiller has scales, but it also has thick, flexible skin that helps it breathe and crawl on land. It also has special bones in its skull that allow it to absorb oxygen directly through its skin. Of course, the mudskiller isn't one of those early tetrapods either. It's just an example of a fish that's very well adapted to life both in water and on land. So what did these early tetrapods actually look like? Well, it's likely that they resembled modern lungfish, except with stronger, sturdier limbs that were better suited for supporting their weight on land. These early tetrapods also had a neck, which was useful for keeping their head above the water while their bodies were submerged. Some of these creatures even had necks that were more than twice as long as their bodies. This would have made it easy to lift their heads up to breathe and scan their surroundings for danger. Finally, these early tetrapods had eyes on top of their heads, which is a trait that's also seen in modern amphibians. This placement allowed them to keep an eye on the sky while their bodies were buried in the sand. We may never know exactly what these creatures looked like or how they spent their time on land, but we do know that they changed the course of life on Earth forever. These pioneering tetrapods cleared the way for all of the other vertebrates that would follow, allowing species after species to leave the water and conquer new habitats. So next time you go for a swim, take a moment to appreciate the amazing animals that came before you and paved the way. Many of the images used in this video came from a website, which offers a vast library of royalty-free stock images and video clips for your next project. Thanks for watching. See you next time.